Okay then guys, let's have a look at question 8. Again, we've got an alternating sign, which is always a bugbear, a bit of a pain to deal with. So we're going to have to incorporate something of that nature in terms of the sequence, the terms in the sequence. Incrementing powers of -1s here. But the 10, let's have just look at the numbers now. Half of 10 is 5. A half of 5 is 2.5. So you're timesing each subsequent term by a half, aren't you, from the preceding? So the first one is 10, that's okay. And then minus 10, and you times it by a half to get the 5, didn't you? And then it was 10 times a half squared, times by half again. That gave you the 2.5. And then you've got 10 times a half cubed. Now that was minus, this is plus, this one's minus, which I managed to write as a plus. Let's just change that now, and then it carries on in the same manner. Let's just get rid of this stuff here, give us a bit more room. Okay, good. So that's equal to then. So now let's deal with the alternating sign. It looks like we've dealt with, this is power 1, so this would be half to the power 0, wouldn't it, to write it in the same pattern. So let's do that here. We've got half to the 0. Now we've got to be a bit careful because we've got alternating signs. So the very first term is -1 to the 0, isn't it? That would just still be 1. So this whole thing is still 10. The minus can come in now. And I can write that as -1 to the 1. 10 and a half to the 1. Yeah? That's that second term done, taken care of here. The third term, plus -1 squared, agreed? That's our plus. 10 times a half squared. And then the last term, this minus can be written as plus -1 cubed, can't it? That's our minus. We've got 10 times a half cubed. Now everything seemed to me looks fine and dandy. Fairly happy with that sequence. It continues along there. So what have we got then? We've got 10 is constant all the way through the sequence. Agreed? The -1s are to a power. The half, they're both the same, aren't they? So if r is 0, this would be r and r. And then we've got 10 -1 to the r, half to the r, because they're the same value, aren't they? R equals 1, agreed? So, and the third term, let's just check that. We've got 10. We've got, I'll write it just below, 10 -1 to the r, half to the r, when r equals 2, wasn't it? Yeah, and that would be that term there. That would be -1 squared, 10 and half squared. That's ours too. And this third last term is plus 10 -1 to the r times half to the r when r was equal to 3. Okay then, that's what we've got then. Every term looks identical in form and structure. So we can just simply write out the sigma notation now, can't we? So we've got the sum of 10. Now we could use, do you mind if we use properties of indices straight away, because they're all identical. They're same powers. This to the power times that to the power, I can just combine the numbers. So I've got -1/2 to the r. And I've just used simple properties of indices there. And then it's an infinite sum, wasn't it? Infinite sequence rather. So we have that, or series. Okay then, that's the sigma notation for question 8. Good.